Good morning, student. In the lecture series of differential equation, today our topic is higher order linear differential equation with variable coefficient. Variable coefficient means I already told you when the coefficient of derivative are not constant, or you can say that when the coefficient in the form of x, the function of x, then we call the higher order linear differential equation with variable coefficient. The objective of this lecture to understand about the variable coefficient and solving method of this type of differential equation. So continue with me. We are continuing doing well, find out the method to solve this type of equation. Now we are going to start lecture. Right. We take another example. Yesterday we have done a question on basis of Cauchy-Euler equation. Okay, Cauchy-Euler equation means when the term, when this type of term x squared d2y dx2 plus x dy upon dx, this type of equation we call Cauchy-Euler equation or homogeneous differential equation. Now today we are do the another example. Yesterday we have done a beautiful example on this type of equation. Today we are going to start another question land. Today we will do two examples basis on homogeneous dx. Okay, minus 4 x plus 4 x dy dx plus 2y is equal 1. Second, h x here d2y dx2 minus x dy dx plus 4. Equal to cos log plus x sin. The second one question is looking very crucial to solve it, but this is very easy. Now we taking first one, then we go to the second solution first. Okay. Is see the degree of coefficient and the derivative of order of derivative are same. So this is the homogeneous equation. This is homogeneous differential equation equation of variable coefficient. So we take x is equal to e to power z, imply z is equal to 0. Okay. Now we replace d upon dy upon dx is dy upon dz approximation. Okay. To change now. So we can do here d d minus 1 minus d plus 4 is equal to e e to power. Now by solving this we get d square minus d minus d square 4 y is equal to e to power. Here become d square minus 2d plus 4 y is equal to this is equation 1. Now we'll write auxiliary equation. Auxiliary equation का होगा m square minus 2m plus 4 is equal to 0. We can write m minus 2 pi. Okay. So m is equal to 2n. The root of this equation we get 2n. So now we write now CF is become C1 plus C2x is equal. This is the okay. This is the CF when the root of differential equation auxiliary equation are real but same. Now CF for Ti we get d square minus 2d plus 4 e to power. We can write this like d square d minus 1 here a question here plus 4d plus 4d plus 4d plus 2. Okay, this is the question. So here we get d square plus 4d 2. So this becomes 3d. 3d and this becomes 3d and 2. The root of the equation is now become again do m square minus 2m minus m plus 2. So we get m minus 2 m. Sorry, by mistake we don't write the 4d here. We write 4. So Now the CF here. Now the CF is m is equal to 2, m is equal to 1. Then CF becomes given e to the power 2x plus c2 e to the power c4. Now come to the CF. Some minor mistake, calculation mistake is here. So I do here 1 d square minus 3d plus 2 e to the power. This is our required theory. Now, we did here you see student that 1 d square d minus 2 and d minus e to the power. Here you see student this is the form of general method and FD is in the form of linear. So we apply here general method. For apply general method we have to partial fraction. So we can write like a d minus 2 plus b d minus. This type of question we have already taken. Here we do the find the value of a and b, d minus 2 and d minus 1 is equal to a d minus 1 plus b d minus 2 upon d minus 1 and d minus 2. This cancel and now become 1 is equal to a plus b d minus a minus what we can write here common. By comparison we get a plus b is equal to 0 and minus a minus 2 is equal to 1. So value of a minus b by adding 1 b is equal to minus 1 and a is equal to plus 1. So this becomes 1 upon d minus 2 minus 1 upon d minus 2. Now we take inside e to power z upon d minus 2 minus e to power z upon d minus 2. Okay, students? Now we give I1 and I2. First we have I1, the solution of this by general method. We can write by, we know the solution by general method e minus 2 get integration e to power z e to power 2z. Okay, students? Now there is so e to power minus 2z e to power z e to power z e to power z. We can write e to power 2z as e to power z and e to power z, then take e to power z as t. So e to power z dz becomes dt. So we can write e minus 2z e to power t e to power 10 is equal to. Now, the integration of this e to power minus 2z, first t as it is e to power t. Integrate e to power t is equal to e to power t minus 1 e to power t. Now, e we assume t is equal to e to power z. So, e to power minus 2z e to power z minus 1 e to power z. By solution we get e to power minus z e to power z minus 1. This is our I. Okay. Now we apply I2. Now I2 part is e e to power z upon d minus d minus 1 I2. Here again by e minus z e to power z okay by general. Here again take e to power z is equal to t e to power z dz. If student you have doubt on general method, then please uh, visit my previous video. Here we take the some example of general method there like b square plus a square is equal to sec ax, t square plus a square is equal to 10 ax. This type of examples I already uh, given and solved. So it will be helpful for you to see this question and solve this type of question. So now we say that e to power minus z e to z e to power z t. Here we replace e to power minus z e to power t or maybe e to power t. So we get z e to power t is equal to e to power t. Put the value of t e to power minus z to e to power. This is the equation number 8. Put both value in. Put the value of I1. So Pi is what is the I1 value? E to power minus z e to power z minus e to power minus e to power minus z e to power. Okay. Now now the solution y is equal to c1 e to power z plus c2 e to power minus 2z plus e to power z e to power z minus 1 minus e to power minus z e to power z. Here we put z is equal to log because we know we already taken x is equal to because e to power z. So z is equal to so y is equal to here c1 e to power log x plus c2 e to power minus 2 log x plus e to power minus log x minus 1 log x. This is the solution. We can solve it easily or make our answer is this becomes x, this becomes x square, this will become 1 upon x, x minus 1 minus 1 upon x. This is our this is our student. Again we'll see important question. So again we will visit and explain you. In this equation, we put x is equal to e to power z and z is equal to log x. Now we know that d square dx square we write and dd minus. Okay, so I replace x square d2y dx2 as dd minus 1 and x dy upon dx is equal to d. Now we find the root. Root we get m is equal to 2, m is equal to 1. So we get the CM. Euler. Okay. Now the solution of PI. The question becomes this PI. Now for solve we use by partial fraction method. By partial fraction method we can write a upon d upon 2 plus b upon d minus 1. We find the value of d, a and b. A and b value we find out and write like that. Now this term we take I1 and this term we take I2. So I1 is equal to e to power z. So this becomes e to power minus 2z. This here we can write e to power 2z as e to power z, e to power z, and e to power z we take t for integration. So e to power ez becomes e to power t. Now by integration, integrate both sides, both term integrate by pairwise, or we can say by islet. We take first and second. First as it is, second integration minus integration, first derivative, second integration. Now again we get this and put the value of e की power t. T की value put करने पे हमें मिल जाएगा solution. Similarly, e की power z upon d minus 1. We take A general solution method. This become by the general method. If, if you want to see about general method, then you go through all the relative videos that I already loaded. So by solving this again, we take t is equal to e to power z is equal to t. So this type we get the solution. And last time when we put z, z can be replaced by z log is equal to log x. So here we put z is equal to log x. We get very important question, very good question. We can say with respect to with the point of exam. Now students, again start the another example, another question we have decided first in this lecture. We will do the two example on Cauchy Euler equation. Now the second one is x square solution to x square d2y dx2 minus x dy upon dx plus 4y cos plus f sin. Now, now we replace x square d2y dx. We take x is equal to e to power z, and so z becomes log x. Now now x square we can write d minus 1 minus d plus 4 y or log x equal to become z plus e to power z sin. This is become our differential equation in the form of z. Now d square minus d minus d equal to cos z plus e to power z. Okay, students, we can write here first of all minus 2d plus 4 y cos z plus e to power z. Now the auxiliary equation. Now the auxiliary equation. M square minus m minus 2 cos sorry, m minus 2 m is equal to minus 2 into plus minus 4 minus 4 into 4 So we get 2 plus minus 4 minus 16 upon 2. So this will become 1 plus minus iota under 3. Now the here now the here when the roots are imaginary. When the roots are imaginary. So the sphere will become e to power alpha x. Alpha is 1 z. So c1 cos under root 3z plus c2 sin root. This is equation. Excellent. First we write the auxiliary. First we replace x is equal to e to power z. So z become log x. Now we put x squared dy dx to replace with d minus x dy dx at d. Make the auxiliary equation and find the root of equation. Find the root of equation we get 1 plus minus iota under root 3. And 1 plus minus iota under root 3 means the root are complex number. And when the root are complex number, the we know that the solution. Just here we can write e to power alpha x a cos theta x plus b sin. Okay. So now the PI. PI is equal to 1 b square minus 2d cos z plus e to power z sin. Okay, separate both terms cos z b square minus 2d plus 4 plus sin z b square minus. So cos alpha z. We know that we replace d square as minus alpha square. So cos z minus 1 cos square minus 2d plus e की power z sin z. D plus alpha 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 is 1. E की power alpha is 1 cos square minus 2 d plus 1 cos z 3 minus plus e की power z d square plus 1 plus 2d minus 2d minus 2d minus d plus here this cancel. Now for make d square we multiply with conjugate become 9 for d square plus e की power z d square minus d plus 5. 1 upon 3 cos z plus 2 d cos z is equal to sin z of this minus differentiation of cos z is minus sin z here and put minus t square minus 1 9 plus 4 minus 1 9 and e to power z Here again minus 1 का square minus 2 plus 5. 3 cos z minus 2 sin z become 5 plus e की power z 4 minus 2. So this becomes 3 cos z minus 2 sin z is equal to 5 plus again we multiply with 4 plus d 4 minus d square. This becomes 3 cos z minus 2 sin z upon 5 plus e to power z 4 minus 1 square is equal to become plus 1 or this becomes 4 sin z plus. So our PI becomes 3 cos z minus 2 sin z upon 5 plus e की power z 5 4 sin z plus 4. Now the complete solution y here e की power cf plus ci. Here what is the value of e की power z? c1 cos c2. E की power z c1 cos under 3z plus c2 sin under 3z plus 3 cos z minus 2 sin z 5 plus e की power z 5 4 sin z plus 4. Now put z is equal to log x. So e की power log x c1 cos under 3 log x c2 sin under 3 log x plus 3 cos log x minus 2 sin log x upon 5 plus log x e की power log x become x 5 4 sin log x plus cos. So this is our complete solution, friend. Now take time for quiz. Now the time for quiz. Cauchy-Euler differential equation is also known as homogeneous differential equation. Homogeneous equation of variable coefficient. P1 is the coefficient of dy upon dx. When we go to the exact form, then I will tell you how to write the linear differential equation. Then you find that P0 is the coefficient of d2y dx2 and P1 is the coefficient of dy upon dx. In homogeneous equation, we take x is equal to e की power z. Okay, we assume x is equal to e की power z. If we sin z, if sin z, z is equal to, we put log x and sin log x. In last example, you see when the sin z we put z is equal to log x, so become sin log zx. dd minus 1 term means is d2y dx2 because we take dy upon dx as dy upon dz upon dx. So it convert in dd minus 1. The pi of e exponential and exponential z. We can also write e to power z. Then this question, this pi is immediately in this video. First lecture, first example is based on this pi e to power z. Then we find the pi. So students, uh, thank you very much to watching this video, and I hope that homogeneous equation, that means the Euler-Cauchy equation of homogeneous form, you have clear in your mind. So please keep continue to watch my video and support me. Thank you very much. This is very beneficial for your exam point of view.